Does it start? Yes, it did. Okay, so we are asked to show everything. When we're asked to show everything, is that infinitely many steps that we have to go through, and of course the table. Okay. So I look at the function, and my first step is to clean it up. If you don't want to say simplify, organize, factor, whatever you want to say, I'm going to say clean it up. So first of all, I don't like the numerator. It's not in descending order. And the denominator is not in descending order. Now it is. Then I will say, I will factor out x in the numerator. And I will factor the denominator into x minus 2 and x minus 1. Stop. Do not simplify anything. Not at this point. We have to state the domain first. So the domain is any real number between negative infinity, infinity, except 1 and 2. Get ready to create a new table if it gets too crowded. If you remember the first function that we looked at, my table was too crowded and I had to use the landscape because I couldn't read anything. It was there were too many one next to each other. Now,
So
yes.
Just to ask a question. So 0 isn't included. You just
0 has to be in the table no matter what, because it will be one of the important points. When x is 0, y is something, which is the y-intercept. Very good question.
So, this is all cases,
yes,
0.
Except if it's undefined. And even if it's undefined, I have to write that it's undefined. So 0 will always be in the table because I need the x and y intercepts. So for the y-intercept, I will have to plug in 0. This is not a monologue. So don't ever say, sorry for asking a question. No. Please, that's why we are here. That's why I'm here with you. Please. It's never interruption. Unmute yourselves anytime if you have a question. Okay, now I can do this. And I realize that since this factor disappears, I have to say that x equals 1 is a whole, because it goes away. And then the function is negative x over x minus 2. And I know that x equals 2 will be a vertical asymptote, guaranteed. So I already made my own notes from, so here's what I found so far. Domain, whole, vertical asymptote. In a blink, these three are right there. Yes, I realize that when I plug in 0, 0 over negative 2 is 0. So I have to put 0 in the table. Now, there is no other x-intercept because this is 0 only when the numerator is 0. I will not consider this done before I find this limit, this limit, this limit, this limit, this limit, and this limit. Only then I can look at the first derivative. So, limit of negative x over x minus 2 as x approaches infinity, and when x approaches negative infinity will be the same. How do I determine this limit? Any method?
Plug it in.
Yes, we have to plug it in. Awesome. We always do that. And since it's what I like, what will you do? I like this one.
Flip tiles.
Yes. So the top prime is 1. The denominator prime is 1. So then the limit is?
Negative 1.
Negative 1. So negative 1, y equals negative 1, horizontal asymptote. Negative 1, y equals negative 1, horizontal asymptote. Left and right of the whole now. Limit as x approaches 1 from the left, from negative x over x minus 2. And yes, I know you're going to say plug it in because we have to. We have to plug it in. Can anyone give us the answer?
1.
Yes, because the top is 1, the denominator is -1, but there is a -1 in front, so this is 1. You don't have to determine the other one if this is the whole. So 1 comma 1 will be the whole. The limits have to be the same on both sides. Now, not here. Not here. We cannot conclude. So here's a different story. So here limit as x approaches 2 from the left of -x over x minus 2, and then limit as x approaches 2 from the right from -x over x minus 2. Yes, you will say to plug it in, the top will be 2 or -2. If you want to, we always connect, I shouldn't say always, but we want to connect the sign with the top, and the denominator is 0. So the top is negative and the denominator is 0. And we know that this is no hope. We can only write this or this or this. Which one is it in the first case?
Negative infinity.
So with 1.9, this is negative. With 1.9, this is negative. And the top is negative.
Positive?
Yes, yes. Now, with 2.1, this is positive. But this is negative. Positive, negative.
Negative infinity.
Awesome. So, immediately go to the table. Do not leave this information lying around, because the moment you find something, go to the table. Find something, go to the table, because it will be buried in the gibberish and you will not be able to extract it. So every time I find something, I go directly to the table. Now this is complete. There is nothing else I can find about the function from the function itself. This is done. Now I'm free to move on to the first derivative. And no, we're not differentiating this. We're differentiating, and we continue all the way with a simplified form. I love this example. Thank you for choosing it. Okay, so then our function again here is a -x over x minus 2. Which rule applies here to of differentiating, please?
Quotient.
Yes, thank you very much. I put x minus 2 squared immediately so I don't forget. Top prime is 1, x minus 2 minus top times the bottom prime, which is 1. Nice. Negative with -2, so this is 2 over x minus 2 squared. Now I need the critical numbers. They can come from f prime of x being 0 or f prime of x being undefined. But this is undefined for what value of x?
2.
So is the function. So this is no critical number. When is this function 0?
Never.
Never. None. What is the sign of this expression? Always and forever.
Positive.
That's it. Now, stop. And make sure that my table is valid. This is when I catch my mistakes. I say, oops, that doesn't make sense. So let's see if it makes sense. From -1. Yes, go ahead.
Okay, I kind of just got confused. Could you reiterate after we found the derivative? After we, differentiated that.
So what was the question?
Just from that point, just re-explaining before you filled in the table.
Yes, a fraction is 0 when the top is 0. But 2 cannot be 0, so there is nothing coming from this. This fraction is undefined indeed at x equals 2, but so is the function. So it cannot be a critical number. A critical number has to be a point that exists, but there is no point that exists at 2. So the second source says when f prime is undefined, but the function exists there. but the function does not exist at the value of x for which f prime is undefined. It does not exist. But the function does not exist, so it cannot be a critical number. Okay?
Okay.
Ask if there is something else.
And also, you put in the positive, you put in the pluses because of what?
No matter what you plug in here, it's squared. Anything you plug in, it doesn't matter. If you square it, it will be positive forever.
Okay.
And 2 divided by positive forever will always be positive forever.
Okay.
Better?
Mhm.
Good. So now I have to make sense of the information. And then I say, oops, if it's needed. So from -1 to 0, the function is increasing, and that is supported by the sign of the first derivative. Accepted. From 0 to 1, yes, accepted. From 1 to infinity, yes, accepted. From -infinity to -1, yes, accepted. So these two rows work in sync. All my numbers, everything I found is increasing. Now I will move on to the second derivative. I will not differentiate this. You already know me. I'll try to make my life easier. Why? Because there is no x in the numerator. What's the point in using the quotient rule if I don't have to? So I change it into this. And then the second derivative becomes -4 x minus 2 to -3 times the inner function prime. But that is 1. So this is -4 over x minus 2 to the third. Remember, you cannot conclude about x minus 2 to the third because power 3 could be positive or negative. Here I was able to conclude because immediately that this is always positive because the power was 2 or 4 or 6. But if it's power 3, I don't know. Both options are on the table, right? So in my mind or on paper, of course, this is never 0, right? And it's not undefined because it's undefined at 2 where the function is undefined. So, but I need to study the sign. Why? So because I have to put it in here. I have to put the sign in there. So in my mind or on paper, I will just replace this by this. So I still have power 3, power 2 times power 1, but I don't have to look at this because this is always positive. It bothers me. If it's always positive, don't waste your time. So x minus 2 will give the sign with a minus in front. So the sign of the second derivative is based on -1 over x minus 2. So a sign to the left of 2 and a different sign to the right of 2. So let's plug in 0. Plug in 0 and tell me the sign. I only care about the sign because I need the sign to the left of 2 and the sign to the right of 2. What is the sign to the left of 2? Plugging in a number to the left of 2 like 0.
Negative.
So 0 minus 2 is -2 with minus in front.
Positive.
Positive. So before 2, the function must look like this. After 2, so let's plug in 10.
Negative.
Correct. Notice that I do not put those numbers up here. They're not relevant. They're only relevant for us and not for the table. Okay. Now it's done. Of course, there is no symmetry, and I should write that. Not symmetric to show that I checked. Not symmetric. And very simple, why? It cannot have a hole at 1 and a vertical asymptote at 2 and be symmetric of any kind. Now, all this is gibberish. Doesn't mean anything anymore. I don't care for anything. I did all my work. I included everything in the table. Only the table speaks right now. Nothing else. Everything else is work that is not relevant anymore. That's it. This tells me how to graph it. And who knows what page am I on? I think I'm on 5, yes. Okay. So here's my graph. I have to start with the asymptotes. So one asymptote is y equals -1. The other asymptote is x equals 2. Then I have to present a hole at 1, 1. Then I have 0, 0. And I don't have anything else. So now let's analyze this. Where is my notebook or my calculator or something to cover? So it's coming from -1, increasing, opening up to 0. Fine. Continues opening up, continues to increase to the hole. Fine. From 1, from the hole, going up to infinity, still opening up, still increasing. Fine. Final step, piece. From -infinity on the other side of the vertical asymptote, from -infinity, opening down, increasing to -1. Opening down, increasing to -1. This is the function. F of x, x minus x squared over 2 minus 3x plus x squared. It was a very good example. I loved it. Thank you. You realize that all the work is in the background. But once we have the table and all the information is in the table, I don't care to look at any of this. It's actually impeding me. It's in my way of graphing. That's all I need, this table. All the information is here. Every step is here. All I need to look at is here and come up with a graph. Any questions?